Hi everyone, welcome to
amazing channel of Brilliant Katha.
When you are rubbing one body with another body, electrons are transferred from one object to another object. Okay, this process, this type of electricity is been given a name.
halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Brilliant Katha.
Hello dear students, good evening. Welcome to today's DPP discussion session. Today we are going to discuss chemistry first. So we have questions from chemical bonding, coordination compound and D and F block element. Chemical bonding I think we already did. Yes, Hanna. Dear students, join fast, we can start the session. Yes, hello, Shiny Sabu, yes. I think people are joining. Let us start now. So today's question we are going to discuss from coordination compound and D and F block elements. So let us start our session. Yes, good evening Hannah, good evening. Good evening all. We are going to start. Question number 1. See, the first question is, which of the following has the highest molar conductivity in solutions? As you know, molar conductivity directly depend on number of ions produced. They gave coordination compounds, you know that one, coordination entity and all we learned. See, when coordination compound dissociates in aqueous solution, the species inside the coordination sphere, that is called coordination entity, they will not dissociate into simple ions. So here you know that one, maximum number of ions means obviously the option will be A, because the compound PT NH3 6 times, PT NH3 6 times, then coordination compound Cl4. This when dissociates, you know that one, what you will be getting? This when dissociate, you will be getting PT NH3 6 times, coordination compound 4 plus 4 Cl minus. Correct. Then total number of ions produced is 5 ions. 5 ions means maximum number of ions. Here it will come only 3 ions. Here it will be 2 ions and here it will be 4 ions. So maximum number of ions 5 ions. So maximum number of ions means yes, maximum conductivity Nabih. Yes, Nabih. Correct answer is option A. Okay, so correct answer is option A, maximum number of ions. So we will go to the next one. Hope you understood. Question number 12, which is low spin complex? You know that one, complexes are given FeCN 6 times 3 minus and CONO2 6 times 3 minus, MnCN 6 times, all of these. See, low spin complexes means you know that one, if the ligands are strong field ligands. Okay, so strong field ligands means pairing up of electron will take place. Pairing up of electron when takes place means there is no unpaired electrons. You know that one, CN is a strong field ligand, SFL. NO2 is a SFL, strong field ligand, and CN is a strong field ligand. So all these cases pairing up of electron will take place. Yes. Yeah, Hanna, correct answer is not A. Here it is Fe, Cn 6 times, Cn is a strong field ligand, NO2 is NO2 minus is a strong field ligand, Cn again strong field ligand. All these pairing up of electron will take place. Pairing up of electron will take place means you know that one they are low spin complexes. So correct option is what? Correct option is D. All of these. Everywhere pairing up of electron will take place because they all are strong field ligand. So whenever strong field ligands are attached, you know that when pairing up of electron will take place means they will form inner orbital complexes. And here we can say that in all these cases the hybridization we can say that there will be here it will be inner orbital complexes only will be forming Fe. Fe3 plus is the ion forming, so pairing up of electron will take place. Here it is CO3 plus, here it will be Mn3 plus. Okay, after removing the electron will pair up because they all are strong field ligands, so inner orbital D2sp3 hybridization will come. Yes, correct answer is, so D2sp3 hybridization means you know that one, so D2sp3 inner orbital complex. Inner orbital complexes means they are low spin complexes. Okay, fine. Question number 13. So the 13th one, the question is, the complex showing a spin only magnetic moment of 2.82 Bohr magneton. I think 2.82 Bohr magneton means it should be root 8. Many values we did, I think. So root 8 should be there. Root 8 means number of electrons should be 2. Number of means number of unpaired electron. Number of unpaired electron is equal to 2 means then only you will be getting. So number of unpaired electron means I think the correct answer will be NiCl4. If you want we can check. You know that one Ni in this one is 2 plus oxidation. Okay, so Ni is in 2 plus oxidation state means electronic configuration will be 3d840. You know that one 3d8 means we can represent like this one. Okay, so electron will be 1, 2, 3, then you know that one 4, 5, okay, then 4, 5, then 6, 8. But you know that one 5, 6, 7, 8. You know that one here one this will be pairing, it will undergo a pair up of electron. Then you know that this one they are asking, sorry, it's a weak field ligand, correct, yeah. So it's a weak, so 1, 2, 3, 4, 5, 6, 7, 8. So how many unpaired electrons are there? Correct, N is equal to 2, see, Cl. So N equal to 2 means we will substitute into the equation mu is equal to root of N into N plus 2, okay, correct. Then is equal to root of 2 into 4 is equal to root 8. Root 8 is equal to 2.82, correct. So right answer is option B. Hope you got. Yes, yes, Irshad, Muhammad Irshad, correct, yeah. Ashmita, yeah, correct answer is B. So correct option is B, that is 2.82. Shall we go to the 14th one? Then the 14th one is, yes, which one of the following is a square planar structure? Another easy one, you can tell the answer. Which one is the square planar? Yes, square planar structure is which one? You know that one here square planar structure will be for this one. Which one? Here I think the first one, because again here it is Ni2 plus. Okay, Ni2 plus means as I told you it is 3d840. So 3d8, but here you know that one. Here you know that one pairing up of electrons will take place. 8 electrons are there. Okay, 1, 2, 3, 4. Should not do like this one. To save time, we will be doing like this 1, 2, 4, 6, 8. One electron, one orbital is vacant over here. Okay, one orbital is vacant over here means we know that one here they are giving square planar structure. Square planar structure means what is the hybridization? DsP2. Tetrahedral means sp3. Because here they are giving the coordination number 4. Coordination number 4 means 2 are there. DsP2 or sp3. Here square planar means DsP2. Here you know that one orbital is vacant over here in D. So this here we can use one orbital to donate lone pair from ligand. Then another one here you know that one another P is there. 2 we will be using because total 4 ligands. So the correct hybridization is DsP2. So this is 3D and this is 4s and this is 4p. Correct. So DsP2 hybridization. Yes, Ashmita. So correct answer is option A. Okay, here what is the hybridization? Here it will be sp3 because Ni is in zero oxidation state. So zero oxidation state means these two electrons from S will come over here. Then sp3. Hope you understood. And this one will be, you know that one there is no pairing up, again sp3. Okay, so hope you understood. We will go to the 15th one. So question number 15 is, in C2O4 thrice, you know that one, that is oxalate ion. Cr(C2O4) thrice 3 minus, the isomerism shown is, it's quite easy, you know that one is a homoleptic complex. Homoleptic complex with the coordination number 6. So there is no chance for geometrical isomerism, no GI. So geometrical isomerism is not there because it's a homoleptic. Homoleptic means only one type of ligand. Then after that, what? Optical isomerism will be there. So optical isomerism, if you want, we can draw the optical isomerism. It will be like this one, Cr. 1, 2, 3, 4, 5, 6. Coordination number is 6. C2O4 means, you know that one, we will be representing OX. So I can put one OX over here, okay, another OX over here, another OX over here, and you know that one, this will be representing as, this will, yeah, here it will be 3 plus, okay. Then you know that one, we can take the mirror image of this one, then we will be representing 1, 2, 3, 4, 5, 6. Here it will come OX over here, and this is the OX, and this is the another OX over here, and this is the 3 plus, you know that one. If this is D means this is L. So optical isomerism definitely will be this, yes. Yeah, correct answer is yes, Hanna. Ashmi, the correct answer is what? Here, you know that one, the isomerism shown by, what isomerism will be shown by? See, it's, yeah, correct answer is optical. So no chance for GI, okay, because it's a homoleptic complex. So only optical isomerism will be exhibited by that compound, okay. Hope you got. Yes, correct answer is option B. We will go to the 16th one. Yeah, 16th one, it's, I think, repeated question in many competitive exam, JEE Main and all, previous paper also it was there, yes. In an octahedral structure, the pair of d orbitals involved in d2sp3, and always you keep in mind whether it is d2sp3 or sp3d2, the two d orbital involved are dx square minus y square comma dz square. You know the reason? The reason is, you know that one, octahedral complex means, you know that one, here it will be center metal atom 1, 2, 3, 4, 5, 6. You know that one, here the bonds are parallel to the x, y and z axis, right? This, you know that one, x, y and z axis. The bonds are parallel to x, y and z axis. And you know that one, in dx square minus y square, what is their specialty? Their lobes are along the axis. Along the axis, because you know that one, there are 5 d orbitals, and other than these we have 3 more. That 3 more means their lobes are between the axes. So between the axes means, you know that one, dxy, dxz and dyz. So for these 3 orbitals, you know that one, their lobes are along the axis, means here the bonds are parallel to x and y axis, x, y and z axes, and here you know that one, here lobes are along the axis, means then there will be face to face overlap or maximum overlapping will occur. So their lobes means electron density. So here also electron density is along the axis. Along the axis, and here the bonds are parallel to x and y axis, means x and y and z axis, means here x, y and z axes, electron density is there along the axis. So that will make maximum overlapping and stronger bond. So right option for this is which one? Correct answer is dx square minus y square comma z square. Both in d2sp3 and sp3d2, the 2 orbital, d orbital, if they are asking, correct answer is dx square minus y square and dz square. Hope you understood. Question number 16, sorry, 17th one. 17th one. 16 we finished, right? Yeah. 17th one, C6H5 twice PD, that is phenyl PD SCN twice, and C6H5 phenyl and PD NCS. You know that one, here it's quite easy. They are asking what type of isomerism. See, wherever ambidentate ligands, okay, ambident ligands. So wherever ambident ligands are present, what type of isomerism will be exhibiting? That is the easy hint for linkage isomerism. You know that one, linkage isomerism. So we have so many CN minus, okay, NC minus, and the same one SCN minus and NCS minus. You know that one, this is called thiocyanato and this is called isothiocyanato. This is CN minus, cyanato and isocyanato. This, you know, cyanide and isocyanate. We have SCN minus and NCS minus. We NO2 minus and ONO minus. We know that one, ONO minus. These all are ambident ligands. So ambident ligands are there means, yes, ambident ligands are there means they will exhibit what type of isomerism? Linkage isomerism. Okay, that all we learnt. It's an important question. Yes, Ashmika, correct. Yes, Ashmi, the correct one is linkage isomerism. Correct. Question number 18. So this is the direct one from D and F block elements. You know that one, D and F block elements, action of heat on potassium dichromate. You know that one, potassium dichromate, we learned K2Cr2O7 on strong heating gives K2CrO4, potassium chromate, and Cr2O3 plus O2. This is the decomposition reaction. Both KMNO4 as well as for K2Cr2O7, action of heat we learned. Yes, decomposition we learned. K2Cr2O7 on strong heating gives potassium chromate and chromium trioxide and oxygen. Okay, potassium dichromate on heating is potassium chromate and chromic oxide or chromium trioxide and O2. So you know that one, the correct answer is Cr2O3. See, this equation we learnt on D and F for directly for action of heat on potassium dichromate. Question number 19. Question number 19, atomic radii of titanium. See, this is the application of what? Lanthanoid contraction. You know that one? Lanthanoid contraction. We know that one. There are so many consequences. One important consequence of lanthanoid contraction is that 4D and 5D. Elements in 4D and 5D are having same atomic size. Which all elements are having same atomic size? You know that one? Zirconium and hafnium, niobium and tantalum, and molybdenum and tungsten. These all elements, and you know that one, titanium is just above the zirconium. You know that one, they are in the fourth period, titanium, vanadium, that all, okay, chromium. So these, when you consider, you know that one, these two are having same size. Not only these two, these three pairs, zirconium, hafnium, niobium, tantalum, molybdenum, tungsten, all they are having same size due to what? Due to lanthanoid contraction. So titanium is bigger than the zirconium. Zirconium and hafnium are having same size. So correct option is which one? Correct option is, yeah, titanium, where it is, yeah, this is the correct option is zirconium and hafnium has the same size. So titanium is this one, above this one, so below this one it will anyway size increases. So titanium is smaller, but zirconium and hafnium are having same size. Hope you got. Yes, that is application of lanthanoid contraction. So we will go to the last question. Okay, next is, yeah, question number 20. Question number 20, the spin only magnetic moment in Bohr magneton, that already we discussed, in Ni2 plus. See, already we discussed this one. In Ni2 plus means, you know that one, Ni2 plus, what is the number of unpaired electron? Is equal to 2. We discussed, no? In d orbital it will be, you know that one, 1 2 3 4, okay, 5 6 7 8. You know that this is, you know that one, 4 5 6 7 8. You know that one, here it is n equal to 2. N equal to 2 means we have the equation mu is equal to root of n into n plus 2. So substitute the value is equal to 2 into 2 root 8. 2 into 4. Here it is 2 into 4. So root 8 is equal to 2.82. Correct. So correct answer is this one. Which one? 2 point here, Ni2 plus. So right answer is which one? 2.84. Yes. So questions are over. So practice the question, same type of question. You can expect the same type. And thank you all. See you on next day. Bye bye.
Good evening students, welcome back. We proceed the live discussion. Today we discuss the chapter electrostatics. Okay, the question is, a parallel plate capacitor has plate area 40 centimeter square and plate separation 2 millimeter. Okay, this is the question about a parallel plate capacitor. The space between the plates is filled with a dielectric medium of thickness 1 millimeter. Actually the plate separation here is 2 millimeter and the thickness of dielectric constant is 1 millimeter. And the dielectric constant value is given 5. The capacitance of the system is, you know, in the case of this parallel plate capacitor, if a dielectric medium is partially filled there, we consider this as the series combination of two capacitors. One is air between and the other is the dielectric there. Okay. Now, the effective capacitance, we can find the equation of effective capacitance in the case of series combination, that 1 by C effective is equal to 1 by C1 plus 1 by C2. Isn't it? Now this is equal to 1 by, what is this? C1 is the capacitance of the capacitor in which area is the medium. That is epsilon naught A divided by separation between the plates. Actually, what is the thickness of air here? Consider this separation is D and the thickness of the dielectric slab is T. Then what is the separation of air, or what is the thickness of air? See, the actual separation of plate is D, in which the dielectric slab is T. Then what is the thickness of air is D minus T, isn't it? D minus T. So this is D minus T there, plus 1 by C2. What is C2? Is the capacitance of the dielectric slab. Capacitance of dielectric slab is 1 divided by, what is the capacitance is? Epsilon naught K, then same area A divided by the separation or the thickness of the dielectric slab divided by T. So T coming here. Clear? Now here we can do one thing. Take D outside and also epsilon naught A outside. Then we'll get, this is epsilon naught A by D is the capacitance. Epsilon naught A by D we can take it. This is the capacitance of the air capacitor. Okay, then here it is 1 minus T divided by D plus T divided by KD. We get it. Okay, this is 1 by C effective of the capacitance of this combination. Clear? Now what about the C effective value? C effective value is equal to, take this reciprocal of this one, that is epsilon naught A by D divided by, that is 1 divided by 1 minus T by D plus T divided by KD. Okay, yes. Now what this epsilon naught A by D? Epsilon naught A by D is the capacitance of this one. Here in the question, area is given 40 centimeter square. Then separation is given, D is 2 millimeter. Okay, then the thickness is given in the question. The given data are, see, area of the plates is 40 centimeter square, 40 into 10 raised to minus 2 meter square. Okay, now the separation of the plates 2 millimeter, that is 2 into 10 raised to minus 3 meter. Then the thickness of the slab T is equal to 1 millimeter, that is 1 into 10 raised to minus 3 meter. Clear? And epsilon naught is there. Actually epsilon naught is in the options also. So you can put here 1 minus, this is 1 by 2 plus 1 divided by, and this dielectric constant value is given that K. K is that 5. Okay, put in this value, we get the answer is this one 10 by 3 epsilon naught F. Okay, this is simple substitution. 1 minus 1 by 2 plus 1 by 2 and K is 5. Okay, area is 40 centimeter square, 40 into 10 power minus 4, and this thickness is 2 millimeter. This is 2 into 10 raised to minus 3. You substitute this value, we get the answer is 10 by 3 epsilon naught farad. Okay, yeah. Moving to the next question. The electric potential at the center of the two concentric half rings of radii R1 and R2 having same linear charge density lambda is same the charge density of this wire and this wire is same lambda. Okay, we have the electric potential at the center of a circle. Suppose this is a charged circle. At the center, the potential V is equal to KQ divided by radius. KQ divided by radius. Okay, if it is a semicircular one, then what is that? KQ by R. Now this Q is the charge of this wire. Charge of this wire. Okay, now this is K into, what the charge on the wire is? Lambda into distance. Distance is pi R. Okay, divided by R. R is cancelled. This is K lambda pi. Clear? This is the potential at the center of a semicircular wire, K lambda pi. Okay, here the lambda of both wires are positive, so we have to add the potential there. Potential is a scalar quantity, we should add. The total potential V total is equal to V1 plus V2. V1 plus V2. Okay, this is K, see, K then pi constant. Then lambda 1 plus lambda 2. Lambda 1 plus lambda 2 is lambda plus lambda, it is 2 lambda. Okay, it is 2 lambda, it is, yes, 2 lambda. Okay, now what the value of K is 1 by 4 pi epsilon naught. Now this is simple substitution, 1 by 4 pi epsilon naught, then pi is here 2 into twice of lambda. Okay, then this pi is getting cancelled. Then what this is, the answer is 1 divided by 2 epsilon 0 into lambda. Lambda divided by 2 epsilon 0, that is option B. Okay, very direct question, scalar addition of two scalar quantities. Now the third question is, capacitance of an isolated conducting sphere of radius r1 becomes n times when it is enclosed by a concentric conducting sphere of radius r2. Consider this a conducting sphere of radius r1. What is the capacitance of a sphere is 4 pi epsilon naught into radius. Clear? For a single sphere, this is the capacitance, isn't it? Now, if it is surrounded by another sphere, now these two spheres, concentric spheres, now the capacitance is changed to that 4 pi epsilon naught, then the product of the radii r1, r2 divided by the difference of radii, okay, which is greater radii. Let this be r2, let this be r1, let this be r2. Now, this is r2 minus r1. This is the formula, okay. Keep this formula in mind. This is the capacitance of two concentric spheres. Okay, and this is the capacitance of a single sphere, 4 pi epsilon 0 r. Okay, now here the question saying that if it is surrounded by this another sphere, the capacitance becomes n times, which means this value is equal to n times of the earlier value. N times of the earlier value means n into 4 pi epsilon 0 r1. Okay, now 4 pi epsilon 0 is cancelled. Okay, and the question asked is r2 divided by r1. 4 pi epsilon 0, 4 pi epsilon 0 is cancelled. We get this r1 r2 divided by r2 minus r1. Okay, this is equal to n times of r1, and r1 is also cancelled. Okay, now we are having this r2 minus r1 divided by r2 is equal to 1 by n. Isn't it? Yes. Now this is 1 minus r1 by r2. This is simple calculation only. This is 1 by n. R2 minus r1. So this is r2, r1 minus r1 by r2 is equal to what? 1 minus 1 by n. This is n minus 1 divided by n, and we need the reciprocal of this one, that is n divided by n minus 1. Isn't it? N divided by n minus 1 is the answer. N divided by n minus 1, which is option A. Okay, very simple. Now, fourth question is, two uniformly charged spherical conductors A and B of radii 5 millimeter and 10 millimeter. There are two spheres, one sphere of radius, let it be r1, and the another sphere of radius r2. Okay, initially we take so. Okay, values of radii given 5 millimeter and 10 millimeter are separated by a distance of 2 centimeter. These are separated by a distance of 2 centimeter. Okay, yes, 2 centimeter. Now, if the spheres are connected by a conducting wire, then in the equilibrium condition, the ratio of magnitude of electric field at the surface of sphere A, let this be sphere A, let this be sphere B. The ratio of electric field at the surface of A, EA divided by EB is asked after the equilibrium condition is set. Equilibrium condition is set when these two spheres are connected by a wire, there will be charge redistribution. Charge sharing will be there till the potential becomes same. Okay, till the potential becomes same, and after the potential becomes same, let the charge here be Q1 and the charge here be Q2. Okay, then the potential of first sphere and potential of second sphere are equal, which means KQ1 divided by R1 is equal to KQ2 divided by R2, because there is the potential formula KQ by R, isn't it? K cancel, and we are having this Q1 by Q2 ratio is Q1 by Q2 ratio is equal to R1 by R2 ratio. Keep this in mind. And what is the field equation value of a sphere? The surface field of a charged sphere is KQ divided by R square. KQ divided by R square. Then what is the ratio? E1 divided by E2. Otherwise EA divided by EB. EA divided by EB. We can take E1 divided by E2. E1 divided by E2 is equal to Q1 divided by Q2 into R2 divided by R1 whole square. Isn't it? Now what is Q1 by Q2? Q1 by Q2 is R1 by R2. Okay. R1 by R2 into R2 divided by R1 whole square. Okay. Now this one is R2 divided by R1. R2 divided by R1. Okay. And what is R2 given is 10. 10 millimeter will be cancelled. 10 divided by 5 millimeter is cancelled, and 2, the answer is 2:1. 2:1 is the answer. Okay. The idea is when this is connected with the conducting wire, there will be charge distribution till the potential remains same. Till the potential remains same, you get a ratio of charge. Okay, it's very simple. Next one, the fifth one is two identical thin metal plates has charges Q1 and Q2 respectively such that Q1 greater than Q2. Two identical metal plates are there. One is having charge Q1 and the other is having charge Q2. Okay. Now, were brought close to each other to form a parallel plate capacitor of capacitance C. A parallel plate capacitor of capacitance C. These plates are brought close to each other to form a parallel plate capacitor of capacitance C. The potential difference between them is, what is the potential difference of these two plates when they are brought very close? That is asked, the potential difference. Okay, we know the potential difference value is, there will be an electric field is there. Okay, the electric field is there between the plates, electric field is there between the plate. Okay, and what is the electric field value? Electric field value is, see, the electric field of this one, the field of this one is sigma 1 by sigma 1 divided by 2 epsilon 0, and the electric field of this one is sigma 2 divided by 2 epsilon 0. Here it is said that Q1 is greater than Q2, isn't it? Q1 is greater than Q2. Then the field of this one is in the right direction and the field of this one is in the left direction, because these two are positively charged. Okay, the field due to positive charge is away from the plate. Okay, the field due to this Q2 is away from the plate, means negative, means leftward. Okay, which means the field of Q1 is towards right, the field of Q2 is towards left. Okay, then this net field is sigma 1 by 2 epsilon 0 minus sigma 2 divided by 2 epsilon 0, isn't it? Because one is positive plus minus, because field is a vector quantity, and we have sigma 1 is Q1 divided by A. Okay, Q1 divided by A, then 2 epsilon 0 minus Q2 divided by A, 2 epsilon 0, isn't it? Now this field value is A divided by 2 epsilon 0 is common, 2A epsilon 0 common, then Q1 minus Q2 is in the numerator. Okay, this is the field value. When you get the field value, we get the potential, because what is the potential is ED. The potential difference is ED. Okay, potential difference is ED. What is E is equal to Q1 minus Q2 divided by 2A epsilon 0 into D. Okay, Q1 minus Q2 divided by 2 epsilon 0 into D, isn't it? Now what is this epsilon 0 A by D? Epsilon 0 A by D. Placing this D in the denominator, we get epsilon 0 A by D, that is C. That is the capacitance, isn't it? Q1 minus Q2 divided by 2C, isn't it? Q1 minus Q2 divided by 2C is the answer. Q1 minus Q2 divided by 2C, that is the answer, option C. Understood? So this type of question is very easily done. Okay, clear. Now question number 6 is, a uniform electric field E is equal to, the field value E is equal to 8m by E, 8m by E, where m is mass of electron and E is charge of electron, given. Clear? This much volt per meter. Volt per meter means the SI unit of field intensity is created between two plates. Okay, the length of the plate is 1 meter there, as shown in figure. Okay, now the electron enters, see, an electron enters in the field symmetrically between the plates. An electron is entering between the plates with a speed of 2 meter per second. Electron is entering with a speed of 2 meter per second. The angle of deviation theta of the path of the electron as it comes out of the field is, as it comes out of the field, it is deviated, and what this angle is asked. Okay, see, this one is the final velocity V, and here there are two components for V. One is the y component Vy and the other is the x component Vx. Okay, this is the y component Vy and this is the x component Vx. Clear? Then what is tan theta is equal to? Tan theta here, theta is asked actually, theta is asked here, and we have tan theta is equal to Vy divided by Vx, isn't it? Now this vertical motion is accelerated motion. See, this Vy, why this Vy? Vy is due to acceleration. See, acceleration will be opposite to electric field, so accelerated motion, that's why Vy. So what is Vy value is equal to? Vy value is equal to Uy plus Ay into T. Okay, what is Uy? Initial vertical velocity is 0, and what is acceleration along y direction is, there is force by mass, E by m. Force by mass is acceleration, and time interval is, the time interval is time taken to travel this much horizontal distance. This much horizontal distance to travel means this is equal to, let this velocity we are taking as u, means this time interval t is equal to s by v. S by v, s is actually s is 1 and divided by u. Okay, we can place the value later. And this S is here 1. So I have put S by U. Okay, time interval. So this is Vy. So what is Vy is E then divided by mu. Okay, divided by Vx. What is this? X component of velocity. X component of velocity not going to change. That is U remaining as U, isn't it? Now we can place the value E into. What is the field value is 8m by E. 8m by E divided by m then U square. Okay, yes. Now E is cancelled, m is cancelled, 8 by U square. And what is U value? U value is 2. 2 square is 4. 8 by 4. Isn't it? 8 by 4 is what? 2. So what is tan theta is equal to 2. So what is theta is equal to tan inverse of 2. Isn't it? Theta is equal to tan inverse of 2. Okay. Here this motion is accelerated. This motion is uniform motion. Because there is no acceleration here. There is acceleration here. So that's why the expression of Vy is U plus At. But the expression of this Vx is simply U. Because it is uniform motion. Understood? Okay. Now the question 7th is a spherically symmetric charge distribution is considered with charge density varying as. This is a spherical body which is charged body, but its charge density is varying. Charge density varying as rho of r is equal to rho naught into 3 by 4 minus r by r for r less than or equal to r. Okay. Up to the radius, the charge distribution is in this way. Okay, the volume charge density rho is in this way, and after r means, okay, after completing the sphere, there is no charge density. Okay, when r is greater than r, this charge density is 0. Okay, question is, at a distance r, there is a point P. What is the electric field there? What is the electric field there? See here, you consider an inner sphere here. Considering an inner sphere here, let Q be the total charge. Considering an inner sphere here, let Q be the total charge. Then what is the field intensity value? E is equal to KQ divided by R square. KQ divided by R square. Now the job is to calculate this Q. What is the Q value? Considering this inner sphere here, suppose we consider a small segment here. Consider a small segment here whose width is dr, and its area is 4 pi r square. Its area is 4 pi r square means this is the volume of this considered segment. Volume is area into height 4 pi r square dr. Now what is the charge of this segment is dq is equal to rho into v. Okay, rho into v. That is rho into 4 pi r square dr is the charge of this one. Then what is the total charge q is equal to? Total charge q is equal to integration of rho 4 pi r square dr. Okay, from 0 to r. From 0 to r we have to. Okay, here 4 pi is taken out and this rho is the function of small r. This rho is the function of small r. See, this rho is rho naught. So we can write here that is rho naught, then 3 by 4 minus r by capital R. This is the rho value. And 4 pi r square dr. 4 pi r square dr. Okay, integration of this quantity from 0 to r. This is the q value here. Total q value here. Clear? Now we get this as equal to rho naught is taken outside and 4 pi also taken outside. Then in the bracket it becomes 3 and this is r square dr integration. There is r cube by 4 into 3 will be there. Okay, r cube by 3 minus here it is r into r square, that is r cube. So its integration is r raised to 4 divided by 4 and there is capital R is there. Okay, yes, this is the small q charge value. Substitute here and also replace this k as 1 by 4 pi epsilon naught, and what the charge value is rho naught into 4 pi, and within the bracket it is 3 is cancelled and r cube divided by 4 minus r raised to 4 divided by 4r. Okay, now divided by r square here, isn't it? Now 4 pi is cancelled. Okay, now r square is multiplied here into the bracket. Okay, now it comes that rho naught divided by epsilon naught. R square is multiplied into the bracket, means here it is r by 4 minus here it is r raised to 2 divided by 4r. Okay, now r by 4 also can be taken. R by 4 also can be taken, that then what value we are having? See, r by 4, rho naught r by 4, see, rho naught r by 4, rho naught r by 4 epsilon 0, rho naught r by 4 epsilon 0, here it is 1 minus small r by capital R, 1 minus small r by capital R. The answer is option C. Understood? Okay, yes, option C is the answer. Yes, Ashmita Chakravarti and some of you are typing the answer. Very good. Now the 8th question is, two identical metallic spheres A and B, when placed at certain distance in air, repel each other with a force F. Suppose two identical metallic spheres at a separation, identical metallic spheres means they are also equally charged, and they experience a repulsion, and this repulsion is related as F. Okay, now another identical uncharged sphere C, another uncharged identical sphere, it is named as C, is first placed in contact with A, and then in contact with B. Okay, and finally placed at the midpoint. After this contacting, finally placed at the midpoint between the spheres A and B. Okay, the force experienced by the sphere C will be, finally, so listen me, first of all I am calculating this F. What is F? F is K Q square divided by, let this distance be R, let this separation be R, then it is R square here. Okay, now this is placed in contact with the Q, then there will be charge sharing. Charge sharing will be there, and these two are identical spheres, means their capacitance are same. So for the potential become same, charge should be equally shared. For the potential to become same, charge should be equally shared, means this one having charge Q by 2 and C now having charge Q by 2. C now having charge Q by 2, this is A. You understood? And now here at a separation R, there is B. You understood? Now B initially having charge Q, and now this is placed in contact with B. Now the total charge will be shared equally. You understood? Already this is having charge Q by 2 and this B is having charge Q, and the total charge is equal to 3Q by 2. This total charge will be equally shared. You understood? This is placed in contact with B, means the total charge of these two spheres 3Q by 2 will be equally shared. You understood? Now this is 3Q divided by 4 on it, and now this C is placed on the midpoint, means what is the charge on it? This charge is equally shared between these two. This is 3Q by 4, then this is also 3Q by 4. Okay, now there is repulsion in this way and there is repulsion in this way also. Okay, and the net force on C is asked. The net force on C, what the net force on C, we can write that the net force on C, FC is equal to, the greater force is in this way because this product is greater. Okay, now K into product of charge Q by 2, see I write Q by 2 into 3Q by 4. Okay, divided by R by 2 square. R by 2 square is R square by 4 minus, then the force between this is in this way. That's why I am putting minus here. Otherwise plus and minus. Okay, now K, then the product of charge 3Q by 4 whole square. 3Q by 4 whole square is 9Q square by 16. Okay, divided by R square means the separation square. Separation square is R square by 4. Okay, now what are the common terms there? See, this one is K, K is here, then Q square is here, then this one, see this 4 by 4 will be cancelled, this 3 by 2 here, and R square is here, okay, minus, here it is KQ square, and this one is 9 here, isn't it, 9, KQ, and that's 9 is this one. 9 by 16, actually this is 9. Okay, this is 9 and this 16 by 4 is 4 here. Okay, so 9 by 4 R square. Okay, now you can easily solve it. Okay, some common terms are there, and for this kq square by r square you place f. Okay, kq square by r square will be there, for that you place f. Okay, then you will get this will be 3f by 4. Okay, you will calculate this one, there will be kq square by r square, for that you place f. Okay, then you will get the answer is option B, 3f by 4. Okay, yeah. Moving to the next question, number 9. Two identical charged particles each having mass 10 gram and charge is given, mass is given. Okay, mass of the charged particle is given 10 gram, 10 into 10 raised to minus 3 kilogram, and the charge value q on each is 2 into 10 raised to minus 7 coulomb. Okay, these are the first data is here. Okay, now are placed on a horizontal table with separation of L. Consider this is a horizontal table. Now these two charged particles are placed here with a separation L. Okay, now there will be repulsion here because same charge, same polarity, there will be repulsion. Okay, now such a way that in limited equilibrium, they are in equilibrium means the net force is cancelled. The net force is cancelled means, see here, this will be experiencing electrostatic force that is cancelled by frictional force. That's it. The electrostatic force Fe is cancelled by frictional force. Okay. Then the coefficient of friction is given there 0.25. Mu value is given there 0.25, that is 1 by 4. Okay. Find the value of L. That's the question. What is the electrostatic force is K into product of charge Q square divided by separation square is L square, isn't it? And what's the frictional force value is mu into normal reaction. What's the normal reaction value is mg. Okay, mg. See, all values are given here. See, K is 9 into 10 raised to 9 is the value of K, and the charge value 2 into 10 power minus 7 square it, we get 4 into 10 raised to minus 14. Okay, divided by L square is there, this is to be calculated. Okay, mu value is 1 by 4 given. Okay, mass value is given in the question 10 into 10 power minus 3, that is 10 power minus 2. Okay, now this one G is taken as 10. Clear? We'll get L square there, and you can take the square root. We'll get the answer as, I think it is 12 is the answer. Very direct question only. All these are direct summation of these values, and you find L square there. Take the square root, you will get 12 centimeter. Okay, very simple idea. Okay, now moving to the final question is, two identical positive charge Q each are fixed at a distance 2a. Two positive charge fixed at a distance 2a apart from each other. Okay, another point charge Q0 with mass m is placed at midpoint. Here, taking two charges Q are separated by a distance 2a. At the midpoint there another charge Q0 is placed. Okay, this distance is a, this distance is also a. Okay, now see, yes, for a small displacement along the line joining the fixed charge, this Q0 is slightly displaced along the line joining the two charges. This is slightly displaced and released. It undergoes simple harmonic motion. And the time period is asked. Okay, this Q0 is displaced slightly. Let this displacement is x. Now there will be force difference will be there. The force between these two will be less, and the force between these two will be greater, and the net force will be in this direction. Okay, that net force will drag it back, will act as a restoring force. Okay, due to this restoring force it undergo simple harmonic motion. Okay, and what's the time period of simple harmonic motion is asked. First of all, we calculate what is the net force there. The net force on the Q0 is equal to, this greater force is K into Q0, that is the product of charge divided by square of this distance. This distance is a minus x. Okay, this is totally a, this is x, so this is a minus x all square. Okay, that is in this direction, and the force here is in that direction, is in the opposite direction. So I am subtracting this, and Q0 divided by the square of this distance is a plus x all square. Okay, a plus x all square. Okay, the common terms are Q0 common term. Okay, then 1 divided by a minus x all square minus 1 divided by a plus x all square. isn't it? This is equal to Q naught into, this is a square plus x square plus 2ax, take to this side, a square plus x square plus 2ax. Now minus, this is a square plus x square minus 2x, taking to this side is a square minus x square plus 2x again. Minus minus comes there, divided by a plus b into a minus b whole square, that is a square minus x square whole square. Okay, now this a square minus a square cancel, x square minus x square cancel, 2x plus 2x is 4x, and now considering this x square with a square, this is very small, you neglect it, then this is a square all raised to 2, that is a raised to 4. Okay, now this is Q naught, and here it is 4x in the numerator divided by here a raised to 4. This is the net force. Okay, now a and a raised to 4, one a is cancelled there, then the net force F is equal to Q naught, then 4x divided by a cube. Isn't it? Now this net force, when we write it in vector form, this vector F and this vector R in the opposite sense, because force is in this direction and x is in the positive sense, then force is in the negative sense, means here it is a minus there. Now you compare this one with the standard force formula of SHM, that is F is equal to minus kx. We have F is equal to minus kx. For SHM we studied F is equal to minus kx. This k is force constant, and here this k is 1 by 4 pi epsilon 0. Now you compare these two formula, we understand the force constant of this motion is Q naught 4 divided by a cube. X is here, force is here. Okay, the force constant of this simple harmonic motion Q naught 4 divided by a cube is the force constant. Okay, force constant capital K is Q naught into 4 divided by a cube is the force constant. Okay, now what is the time period of a simple harmonic motion is 2 pi into root of m divided by k. 2 pi root of m divided by k, isn't it? This is 2 pi into root of m divided by, what is the k value here? This force constant value is 4Q naught divided by a cube, isn't it? Now this k is what? This k is 1 by 4 pi epsilon 0. This is equal to 2 pi into root of this m a cube, okay, divided by 4 into 1 by 4 pi epsilon naught. Okay, then q into q naught. Okay, now you take this 2 pi into the square root, we get this as 4 pi square then m a cube divided by this 4 cut. Okay, this is into here 4 cut, this pi to the numerator, this pi cube. Okay, now this epsilon naught in the numerator, here it is there. Okay, 4 cut, and here it is q naught. This is the time period of this charged particle. It is given there. You remember this one, 4 pi cube m a cube epsilon 0 divided by q naught. The answer is 4 pi cube epsilon naught m a cube divided by q naught. The answer is option A. Understood? Very good. Okay, students, prepare well. So many such questions are there. Okay, prepare well. Okay, see you soon. Thank you. Good night.
Chat. Hi everyone, hi my dear students, good evening all, welcome back to our amazing channel of Brilliant Qatar. Live DPP session. We are done with maths, you're done with chemistry, you're done with physics, Jamshi sir. Now I'm here back. Chat. Good evening guys, good evening. Hi Vaishnavi. Yes, hi Mr. Shashi Institute, Shashi Mohan. I'm there guys, I'm there. Maybe yes. Hi Ashmita, good evening friend, good evening. Hello Karthik sir, yes, hi Mohan, hi Hannah, hi Vishnu, hi Jamshi. Good evening guys, good evening. Hope you all are doing absolutely great. So guys, in today's session, in today's morning session we have discussed both differentiability and differentiation. We are thorough with complete concepts. We have did some good questions also. I have already showed that particular things in your WhatsApp groups. Sai Stuti, oh my God, is it you? Acha, TK. Hi Triveni, hi sir, how are you? Karthik sir, good evening friend, good evening Triveni, good evening. Hi Shashi, like Stuti. It's you. I don't know that from many days. I thought something Mohan or some other. Okay Stuti friend, fine for TK. We'll start the session, guys. In today's differentiation and differentiability, the first question. First question. Thanks Triveni, thank you. Oh, Mr. Michael Rohit, hello sir, good evening sir, good evening sir, good evening. Missing you sir, missing you in session. Chalo, first question. Log of tan x. Guys, chain rule it is. Chain rule. MK large cap. Hello sir, hello friend, hello. What's your name friend? What is your name? MK large carp. May I know your name friend? May I know your name? So d by dx of log tan x can be written as d by dx of log tan x can, for log it is 1 by tan x into, for tan x it is secant square x. That's it. So 1 by tan x is nothing but cos x by sin x into 1 by cos square x. Cos x gets cancelled, then you get 1 by sin x into cos x, multiply and divide with 2, then you get 2 by 2 sin 2x, which is equals to 2 cosecant 2x. Very good Vaishnavi, very good Ashmita, very good Stuti, very good friends, very good, super guys, super. Nagaraju Bandla, God of Maths arrived. Hi Nagaraju, good evening friend, good evening. It's been long time that we met, man. Thank you for the honor, Mr. Nagaraju. Thank you so much. So guys, this is how, like a simple question but chain differentiation. Okay, see, any question from differentiation is like only conceptual based. If you are thorough with chain differentiation and differentiability concept, like differentiation of different functional concepts that we have discussed in morning session, if you are good with that, everything is fine. Thank you Nagaraj, thank you. I came friend, thanks for your love, support, thanks everything. Second question, d by dx of log x friends, log of log x means, how do you differentiate log of log x? For 1 log x it is 1 by log x, for this log is 1 by log x into, for log x it is 1 by x, so directly it is 1 by x log x, but this can be written as x log x whole to the Ashmita. You're wrong. 4 marks ho gaya. 4 marks plus minus 1, that means minus 5 Ashmita. Option A is x by log x, but option C is 1 by x log x. 1 by x log x is our answer. Very good Rashmika, very good Vaishnavi, very good Hanna. Ho gaya, khatam. That's it. See, that is what friends, that is the reason I took this. And options also, see, the first 1 or 2 options will be like majority, almost 95% more students will be mistaken in a particular way. If they are going to mistake in a particular step, they will be getting either option A or B. So whenever you are marking A or B, you should be very cautious about them. It doesn't mean that A or B won't be the options. Yes, they can be answers, but 95% cases they give these 2 options to confuse us. So be cautious friends, no issues Ashmita, good. All these are like practice makes ourselves better, perfect. Question number 3, d by dx of root x plus 1 by root x whole square. Very good Nagaraju, very good man, you're rocking. Chalo, d by dx of root x plus 1 by root x whole square. See guys, what we do, so simple. First we'll try to simplify this, d by dx of, what is root x plus 1 by root x whole square? This can be like x plus 1 by x plus 2. Instead of differentiating in that way, first time Ashmita wrong. Yeah. Yes. See, first we, instead of taking like x power n into x power n minus 1. Very good, Stuti. Very good. Wow. Rashmika, Ashmita, you answered like anything. Super, ma. Super. Now, what is d by dx of this? For x it is 1, for 1 by x it is minus 1 by x square, and for constant it is 0. That's it, friends. That's it. Super. Option A. Very good, Rohit. Voila. Thank you, Nagaraju. Thank you. Thanks for your love, man. Thanks for your love. Thank you so much. Thank you. Good Vaishnavi, good Hanna. So beautiful, so elegant. Just looking like Abu. Just looking like Rohit. Just looking like Ashmita. Just looking like Stuti. Good, mom. Just looking like Hanna again. She'll be the first one again. Sir, what happened? We use chain rule. Yes, exactly, friend, exactly. Y is equals to x plus 1 by x. Now they are asking us to go with something. See, guys, I have selected this particular question, Stuti. Actually, if you see, directly dy by dx will be 1 minus 1 by x square. Directly you will get it. But in options, if you see, you have a differential equation in terms of y also. Differential equation in terms of y. Hanna, I got your name, man. Why you are crying? Don't cry. We got y also. But how do we get y? My question is, how do we get y? That means we are not supposed to differentiate it directly. You see, if y is on the other side, then directly when we differentiate both sides, what do we get? Dy by dx is equals to 1 minus 1 by x square. That's it. There is no question of y again in the equation. For that, what do we do? Like analyze the, simplify, like do some rearrangements in the question. See, we can like cross LCM. We can take the LCM. For that, you get y is equals to x square plus 1 divided by x. Now that becomes x into y is equals to x square plus 1. Okay. Now clearly, Jakil, crazy with it. I hope to become like one day so funny and so charming. Keep it up, your love, sir. It's Jagruth from class, by the way. Oh, my friend. Oh, my friend. Thank you for such a positive comment, man. Thank you so much. I still remember the smile that you used to make. Thank you, man. Thank you for the comment. So you're crazy. Thank you, man. Love you, man. Love you, friend. Love you. Thank you so much for your love, support, everything, man. Everything. Now you differentiate both sides with respect to x. Very good, Nagaraj. Very good. Now you differentiate both sides with respect to x. This is UV rule. For x into y dash plus y into, for x it is 1, that's it, is equals to 2x. Now you see how you got such a beautiful equation. You will be getting it. Guys. You will be getting it. So directly you get x into y dash plus y is equals to 2x. Now what do we need? V terms of something x square or something else. So x into y dash, or we do one thing, y dash is equals to, now x into y dash is equals to 2x minus y, whereas y dash is equals to x into y dash is equals to 2x minus y. Now friends, actually we didn't get any particular pattern now. What we are supposed to do to get this? What we are supposed to do? We need dy by dx. We need x also. But what can we do? Option A, sir. How? Rashmika said option C. How? See, now once you can do this, see something else, see something like this. Yeah, it can be like, see, sometimes we are not sure that it will be in that particular option itself. We do one thing, friend. We got y dash is equals to 2x minus y by x. Okay. Now let us substitute in. Let's verify options now. Option A. What is option A now? X square into dy by dx. So x square into 2x minus y divided by x plus x into y is equals to 0. Let's see. Here we got x into 2x is 2x square minus xy plus xy is equals to 0. Is it 0? No, it's not equals to 0. So option A is false. Now check for option B. Option B is x square into dy by dx. dy by dx, x square into dy by dx. Dy by dx is 2x minus y divided by x, option B, plus xy plus 2. Now check the x into 2x is 2x square minus xy plus 2 is equals to 0. So minus xy plus 2, but 2x square plus 2 is not 0. Even option B fails. Check option C, guys. Check option C. If you see option C, x square into dy by dx. So x square into 2x minus y whole divided by x minus xy plus 2. Now you see x into 2x, you get 2x square minus xy plus 2. So minus xy is minus 2xy. Now what do we get, guys? 2x if you take common, guys. 2x if you take common, what do we get? X minus y you get. X minus y plus 2. Now 2x of what is x minus y? What is x minus y from here? Minus 1 by x can be written as x minus y. Now substitute that minus 1 by x here. Minus 1 by x plus 2. See, x gets cancelled. Minus 2 plus 2 is equals to 0. Here the thing is, here option C friends. Very good. It's option C. No, it's C. Yes, it is C. It is C. See, here we didn't get anything directly, but after getting y dash, we have substituted it in the options, one among the 4 options, then we got our suitable correct answer. Wow, option C. Hey, Ruben! Hi, man. Hi, good evening, Ruben. Good evening. So that's it. See, the purpose of taking this question is so simple. Sometimes, friends, this was bit confusing. Yes, the thing is, sometimes we might not be getting the result that we got. That is one among the 4 options. So, good evening, guys. Good evening. In that case, what we are supposed to do, we have to make our result according to our convenient options. That's it. We have to make the result according to our convenient options. Excellent. 1 second. I'll be taking this chat a photo. Jakir, loud with that particular comment. Thank you. Next. 1 by d by dx of 1 by x power 4 into secant x. Friends, if you tell me the first step, that's enough. That will be enough. What will be the first step to proceed? What will be the first step to proceed with it? What will be the first step? Guys, I need response from you. It's not a movie to watch. Quotient rule, but do we? Yes, Tuti. Yes. We have to write this 1 by secant as cos x, Ashmita. Quotient rule is fine. Ashmita, good. Stuti, good. Mr. Rohit, sir. Very good. That's it. Take this secant x to the numerator. So what do you get now? You get cos x divided by x power 4. Now find the div by dx of this. That is, now use quotient rule. Friend. Now you use quotient rule. So what quotient rule states that v square, x power 4 whole square, v into u dash, x power 4 into cos x ka differentiation minus sin x. Yes, v into u dash minus u into v dash. U into for x power 4 it is 4x cube into cos x. Anyhow, we can take what can we take? X cube can be taken common, I guess, na? Minus x cube if we take common, then x sin x plus 4 cos x whole divided by x power 8. Then you get minus of x sin x plus 4 cos x divided by x power 5. Option B. Rohit, why you didn't come for morning class? Okay, Hanna, cool. That's it, friends. That's it. Very good, friend. Very good, Stuti. Very good, Ashmita. Super. See, first, the thing is, first important thing is, writing 1 by secant x as writing 1 by secant x as cos x. Then you use quotient rule. Okay. Hi Nagaraju, where were you, man? I am missing your comments. I hope everyone got it. Very good Vaishnavi. Very good Ruben. Fine. That's it. Chalo. Guys, there are two questions. 26th and 27th. Beautiful questions. Beautiful. There are two questions which are so beautiful. Understand the difference between these two. See guys, coming here. In both the cases they are asking us to find dy by dx. Don't get confused. This is a sequence which is not infinite sequence. This is a sequence till n terms. Till it is like n plus 1 terms. Like starting from x power 0 to x power n. So 0 to n means n plus 1 terms. N plus 1 terms. But you see how. What if you differentiate both sides with respect to x? What happens? Dy by dx is equals to, for 1 it is 0. For x it is 1. For x square it is 2x. 2 by 2 factorial. Plus 3x square by 3 factorial. Plus 4x cube by 4 factorial. And so on. For x power n it is n into x power n minus 1 divided by n factorial. Correct? If you see friends, B Sara, y plus hey man, check again, check properly Mr. Nagaraju. Oh, are you giving the answer for previous one? That's so simple. Very good friend, very good Nagaraju, very good. Now coming to this question, Mr. Nagaraj alias Bandla, Mr. Nagaraju alias Bandla. So look here, the dawn of Hyderabad. Now 1 plus 2x by 2 factorial can be written as x by 1 factorial. Nah? Plus 3x, see 3 by 3 factorial is 2 factorial guys. 3 by 3 factorial means 3 into 2 factorial. 3 gets cancelled. 3 Jay here. Hey Jaya, hi Jairam, hi. Good evening friend, good evening boss. So happy to see you guys here. I'm very happy that you all are here. Love you friends, love you. Now that is what that Vaishnavi, Ashmita Chakrabarti again minus 1. 4 minus 1, so you get completely 5. I have seen Ashmita, though you delete, I notice everything. Minus 5, very good. Now x square by 2 factorial, x cube by 3 factorial plus and so on. Look at this, we have x power n minus 1 divided by n factorial. Okay? Okay. Now you see the relationship between given question and this. 1 starts with 1, okay fine. X means x by 1 factorial is x only. X square by 2 factorial, okay. But we don't have x power n by n minus n, x power n by, friends, this is this is n minus 1 factorial. This is n minus 1 factorial. Now except this x power n by n power n, everything we have. So we do one thing friends, we add x power n by n factorial and we subtract x power n by n factorial. Okay. Now if you do understand, from here to here it is clearly dy by dx is equals to y minus x power n divided by n factorial. Y minus x power n divided by n factorial. That is what my dy by dx. Okay. So do not get mistaken. Yes Vaishnavi, good. Hanna missed the last term. I understand. Fine Ashmita, fine. Very good Mr. Nagaraju Mandla. Very good sir. Very good. Now guys, now you have to tell me friends, you have to tell me 27th one. You understood 26th no? You understood 26th no? Now yes Tuti, yes friends, now you understood this no? Now look at 27th one and give me the answer. Rashmika. Previous one is a finite sequence, but this is an infinite sequence. Yeah, I understood, Rashmika. I understood. Y plus 1. All the students who have given option A is correct answer. All the students who have given option A is correct. All the students who have given option A as correct. Mr. Nagaraju again lost 1 mark. No, what is this, Tuti? What is this? How can it be none of this, man? How can it be none of this? How? No, never mind, nothing. Once it is done, it is done. Stuti, negative 1 mark. Stuti, negative 1. Rob, yes. Got this time. Very good, Ashmita. Yes, I have seen. Gone. See, guys, let's see. Find dy by dx. 1. It is 0 plus x. D by dx of x is 1. This is 2x by 2 factorial. 3x square by 3 factorial. 4x cube by 4 factorial, and so on up to infinity. So dy by dx, you get now 1 divided by x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus and so on up to infinity, which is nothing but our same y. I thought it was a finite series. No, kuch nahi, no thinking, no thought. What thoughts are nothing? How can you think? It's infinite. And I'll tell you one most important mathematic, like one important logic of this, one important fact of this, actually. Fact. You know what, friends? You know what? Do you know e power x? In limits, I have given some function expansions. In limits, I have given some functions expansions. Of those, e power x is 1. This expansion is e power x. Here y is equals to e power x, guys. Here y is equals to e power x. This is the expansion of y is equals to e power x. That's the reason. That is the reason. How many times you differentiate y, e power x won't be changed. I hope you understood. Yes, very good, Stuti. That is the reason. In the beginning, you might be like, sir, how e power x differentiation is e power x? How many times you differentiate e power x, we get same e power x? How? This is how. Only faculty give logic which are necessary for competitive exams. Thank you, Nagaraju. Thank you. Love you, man. Love you. So if it is, thank you, friend. Ashmita, yes, Stuti, Ashmita. So it's finite, then dy by dx is equals to y minus last term. Exactly. If it is finite, y minus last. If it is infinite, dy itself. Right, miss Ashmita ji. Yes, sir, got it. Rohit. Oh. Yes, exactly. So see, friends, infinite sequence is exponential one. 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial and so on up to infinity terms is e power x. That's the reason. There is one like meme also based on this particular thing. There is one meme also. The one who, like, there is one particular person who wears complete bulletproof jacket. Okay. So there will be a shooter, like shooting him, keep on shooting him, keep on shooting him. But how many times he fired, like for any bullet he is not going to die. Okay, because he wears that bulletproof jacket. So when he wears that bulletproof jacket, it is nothing but something like e power x. How many times you shoot him, e power x remains same. How many times shooting means differentiating. How many times you differentiate the given function, there nothing changes in e power x. You can remember this fact. I hope you got it. I hope you got this math logic. Say yes. Hanna, what is that? I hope you got this, friends. I hope you got this. Movies are giving us logic now. Obviously, in every movie we can come across like 1 or 2 science parts, boss. In every music, in every movie we come across this. 28th one, they have given y a function in, will never forget it now. Okay, friend. Thank you, boss. Thank you. Very good, Ashmita. Thanks. Wow, amazing meme. Y is equals to a minus z. Then they are asking dz by dy. If you are going to differentiate it, you will never get the answer. Thank you, Miss Vaishnavi. Thank you, Hannah. Thank you. Now see, friends, do understand this. Do understand y is equals to a minus z. They are asking us to find dz by dy. Can we write this as something like this? A minus z is equals to 1 by y. Okay, now z is equals to a minus 1 by y. Now you can find it. Now you can differentiate. Now you can differentiate z with respect to y. That's it. So simple now. So simple, friends. So simple. So dz by dy is equals to, for a it is 1. Sorry. For a it is 0. For 1 by y it is minus 1 by y square. Already we have so plus 1 by y square. So 1 by. But what is y? Y is 1 by a minus z. That is 1 by a minus z whole square, which is equals to a minus z whole square, or z minus a. Anything is fine. A minus z or z minus a. No, Hannah. Rashmika -1. Rashmika -1. Hannah -1. Yes, very good. So that -1 means 5 mark lost. Very good, Stuti. Stuti is fine. Rashmika, okay. No. Anna, I am watching. You are under my surveillance. Ashmita, super. Very good, Rohit. Very good, Vaishnavi. Very good, ma. Very good. See, this has to be done in only this way. If not, see, if you are not going to interchange a minus z and y, then we won't get it. Okay. Chalo. Next, y is equals to x sin x. Then, guys, so simple. Nothing in it. We'll do it. So dy by dx will be now x into sin x ka differentiation is cos x plus sin x. But they are not asking this, ma. They are asking something else also. Guys, okay. 1 by y something. Okay. See, guys. Now, if you do one particular thing, suppose we'll multiply 1 by y both sides. We have this. This is y dash. We to check option A. Now we'll see option wise. When we multiply 1 by y both sides, so 1 by y into dy by dx will be 1 by y means x sin x into x cos x plus 1 by x sin x into sin x. Sin x gets cancelled. Then you get cot x plus 1 by x. Oh God, luckily we got the same. Yes, it is option A. So simple. Very good, Ashmita. Very good, Vaishnavi. Mr. Rohit, fine. Ruben, fine. Rashmika, fine. Stuti again A. Super guys, super. That's it. So simple. Here we didn't get, like, we don't have in dy by dx, we don't have y. But they are asking us to write the value of 1 by y times dy by dx. Okay. Last question for today's session. Till now we have seen like 2 functions in product rule. This is also product rule, but here we have 3 functions. Whenever we have 3 functions in product, what is the rule? Same rule, nothing. We are differentiating one function, 2 function remains same, plus another function, 2 function remains same, plus the remaining one, the remaining 2 functions remain same. That is how we do. It is so simple. I have just taken it to let you know how we differentiate 3 functions in product. That's it. Guys, we'll start with x power. First, we'll differentiate x square. For x square, it is 2x. Remaining 2 as it is. E power x into sin x. Plus, now we differentiate e power x. E power x differentiation is e power x only. Remaining 2 as it is. Next, sin x differentiation is cos x. Remaining 2 as it is. That's it. Friends, that's it. Ho gaya. Khatam. 30 is also A. Oh my God, Stuti. Okay, we'll take x into e power x common. Then you get 2 sin x. Then you get x sin x. Then you get x cos x. Wow, super, friends, super. See, so simple, boss. So simple. There is nothing in this. Very good. Rashmika, very good friend, very good. Vaishnavi, super. Shiny Sabu, super friend, super, so beautiful. Super ma, super. So all my dear friends who have attended this particular session, a big thanks to each and everyone for your love, for your support. At the same time, I wish you all the very best, my dear friends. Make sure I have shared the complete notes. Please make sure you are going through complete differentiability and differentiation, each and every point, mass, each and every point. Okay. Try doing the remaining problems for any queries and all, for any queries I am there with you. I will be there till anytime. I'm not far away from you guys. I am just at a distance of one message or one call away from you. Even the students who are watching this from India, I am not far away from you. I am just at a distance of one message or even a one missed call or even like one single call, anything. Okay. Thank you, Anna. Thank you so much, my dear friend. Ruben, thank you, sir. See you tomorrow. Same, sir. Same. Ashmita, thanks to you all, sirs, for such an amazing class. Thank you so much for your love, friend. Thank you so much. Vaishnavi, thank you, friend. Thank you. See you, sir. Take care. Oh, my friend. Thank you, Jagrut. Thank you. Stutiji, have breakfast and come. Rohit. Thank you. Welcome, buddy. Welcome. Take care. Good night. See you tomorrow. All my dear friends, see you all tomorrow. Friends. Thanks for your love. Take care, everyone. Bye. Bye, friends. Bye. Good night, all. Good night. Take care, everyone. See you, ma. God bless you all. Whenever you have any doubt, my dear friends, please feel free to ping me. Okay? Never forget, please make sure all the tasks which has been assigned to you, complete it, boss, complete it, because we are not far away from JEE. Every day, see, it's already 20 today, tomorrow 21, 20 ho gaya, now 21, just 9 more days in March and like 3 more days in April, that's it. Oh God. Session 2, we have to appear like anything, boss. We should be well prepared, everything. Okay, wish you all the very best. Do your best. Take care, ma. Bye. God bless you all. See you. Good night. Vishnu.